Hi, everybody. Thanks to be here for this talk. The screens are a bit small, so if you have troubles, just tell me, and I will try to increase the font size. Also, you can come a bit further. But I'm Nicolas Frankel. That is my first day at DevOps Day, so I'm very happy to be here. For a long time, I've been a Java developer, team lead, architect, blah, 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 always working in a consulting position, so I saw quite a lot of customers, of projects, of ways to do stuff. Now I'm developer advocate, meaning that my job is to come to you, to give talks, and I hope that you will be happy with it. I started getting interested in Kubernetes like 1.5 years ago when I worked for my previous company. We were a cloud company. We wanted to provide cloud instances. And if you want to automate your infrastructure, well, Kubernetes still seems the way to go. Now I work for a company called Hazelcast. Who knows about Hazelcast? One person. Two person, 3 person, 4. Oh, wait. I wait 5 minutes and perhaps there will be more. No? OK, for those who don't know about Hazelcast, our product, historical product, is called in-memory data grids, Hazelcast IMDG. And basically, you can think about an in-memory data grid as distributed data structures. So instead of having like a simple hash map, you distribute it all over your nodes. Then you start doing distributed system. It gets really, really complicated, but we try to hide it behind a simple API. And our second product is called Hazelcast Jet. It leverages the IMDG to do stream processing in memory. So you can think about it like Kafka, because everybody knows Kafka. But instead of persisting the data on disk, we keep it in memory. So on the good side, it's very, very fast. On the other side, well, you might lose something sometimes. So depending on your use case, you might think about it. Anyway, this talk is not about Hazelcast. The talk is about zero downtime. Why do you want to do zero downtime? Well, the first reason why you want to do zero downtime is probably because of you, or you, or you. Because actually, we are engineers. Well, at least you are. I'm not anymore, but you are. You are engineers. And you want to work on the latest technology possible. So you want to work on zero downtime because it's challenging, because it's interesting. Also, you want to put it on your resume so you can get a better job. So the reason is first you. Who wants here to do zero downtime? Not so many. No, OK, I will wait a bit because I see that it's the first real talk in the morning, so yeah, I need you to warm up and get more reactive. That's fine. The second reason is actually competition. Imagine you're an e-commerce shop, and so you compete with Amazon. If you go on Amazon, there is no downtime, never. The shop is always up. If you want to compete with them, I mean, how crazy would that be to tell your customers, hey, sorry, get back in a few minutes. We are upgrading our application. Doesn't work like that. That would feel like 20th century, and meanwhile, your customer would go on Amazon. So if you want to compete in an area where your competitors already have zero downtime, you need to have zero downtime. And the final reason, who here has a Facebook account? Yeah, that's good. Not that many. Or perhaps you are a bit afraid to tell it. Or a Google account. Yeah. When was the last time you went to Google or Facebook and there was this page saying, hey, sorry, come back in a few minutes. We are upgrading. I mean, it's crazy. If it happened, you would say, hey, guys, you are not really engineers. So your parents, your grandparents, when they use a service nowadays, they expect it to be always, always up. Because some companies are always, always up. So everybody now is expecting zero downtime. So for all those three reasons, you might want, or your business might want, to do zero downtime. And it's very easy. Everybody knows blue-green deployment, right? Yeah. So basically, with blue-green deployment, you have two environments. One is blue, the other is green. One is for production, the other is for pre-production. And at some point, you say, OK, I will switch from the old environment to the new environment. And presto, no downtime. How cool is that? So problem solved. But some amongst you, well, if you were awake, would argue, hey, we have a problem with the database. I mean, we need to copy all the data from the old data. Ah, yeah, you agree with me. That's good. We would need to to instantly copy all the data from the green environment to a blue environment. It doesn't work like that. OK, problem solved. I've been an architect, huh? So that's how it works. You do diagrams and everything is fine. Now, if we dig a bit deeper, actually, it's not as simple, of course. The first is here, when I do my click, I say click, let's switch, and it's instantaneous. But actually, if you have one single entry point, if you have one single load balancer, it's very easy. In general, it's not that case. So basically, you might have some latency between the time when you say, hey, let's switch, and the time your customers are actually switched. The second problem is, what do you do with people who are already on the green environment with all the data? And the final problem that I mentioned is about the database. So either you have a solution to instantly copy all the data from one environment to the other, or you use the same database with the same schema. And Kubernetes comes. And Kubernetes tells you, I will solve all your problems. Why is that funny? And so it comes with something called rolling updates. And rolling updates are pretty simple. So instead of deploying everything at one time, then you have multiple nodes, and then you continuously, incrementally deploy the nodes one by one. How do you do it? Well, you have this resource called a deployment. So before you had replica set, now you have deployment, and you tell it, hey, I want that many replicas, and I want the rolling update strategy to have a max number of nodes and lower limits. And it's done. So if you say, I have 3 replicas and I want max surge of 4, meaning first it will create a new pod, and then it will remove one of the old one, and max unavailable is the exact opposite. So this is how it works. Here at the beginning, I have 3 replicas in V1. I want to upgrade to V2. If I have max surge 1, max unavailable 0, I can add one more. So it will add one more pod of V2 0. Then it will decrease down to 3 by removing one of the old one. And then one new V2, remove one V1, blah, 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 until you get only V2s. And on the opposite side, if you are constrained by your resources, then you can do the opposite. You can be max unavailable 1 and max surge 0. So first it will remove one of the old pod, and then it will add one of the new pod. And of course, you can combine them together, so it's much, much faster. And of course, it's not only about absolute value, but it can be percentages, and it's done. But you might tell me, but the app, they don't start immediately. So how do we know that an app can actually answer the requests? How can they answer the service the request? Who here is a Java developer? Wow. Okay, half the room. Spring Boot developer? Okay, it's the same. Okay, so I am a Java developer, as I mentioned. I will try to, for the half that doesn't know it, to explain it. If it's too light, just please tell me. I don't understand. I will try to answer. There are a couple of seats if you want to sit in the front. So Spring Boot is a framework for Java that allows you to start your Java and Spring project in a matter of minutes, not a matter of days. And it does it by allowing to do convention over configuration. By having this convention over configuration, you can take a jar, put it in your class path, and presto have extra features. One of those features is called the actuator. And actually, it's a set of REST endpoints that allows you to do monitoring, you have metrics, you have health checks, you have a lot of good stuff out of the box. Just put the jar on your class path, you've got everything set. So it's just a matter of wiring Kubernetes into this actuator. And for that, we have the readiness probe, so we can regularly tell Kubernetes, hey, you will consider that this pod is ready when you've got a 200 answer on this endpoint. If you are not using Spring Boot Actuator, you need to write your own, that's fine, but it's done. So it will constantly ping this endpoint. When I've got the right answer, it will say, oh, this pod now is available, and I can continue my rolling update. And that's the end. That's the end. Kubernetes solved all your problems. Kubernetes and all problems are solved. No, actually, if you followed my talk, you'll notice that I didn't address the most important point. And the most important point is the database. I mean, we like to ease the context by pretending everything is stateless. We try to make things as stateless as possible. But at some point, I'm sorry, there is state. There is state. And in general, the state lies in the database. Of course, you also have sessions, you have a lot of stuff, but state in general lies in the database. It can be a SQL database, it can be a NoSQL database, it can be anything, but you have something. So if we apply the principle of rolling updates that I've just shown you to Kubernetes, to an application with a database, this is how it works. I try my rolling update, I deploy version 2.0, and it doesn't work anymore. Like my old pods that were using the old schema, they don't understand the new schema. Okay, it's easy. Then we can make it so that the versions, they are schema compatible. Well, it's easy. I'm an architect, so everything is easy. It's up to the developers to do it, but at least from a design point of view, it makes sense. So let's say that instead of doing that, we will be making our 2.0 application understand the old 1.0 schema. And then we deploy, and we deploy, and we deploy. And at the end, we can finally change the database schema. Everybody's happy with that. Easy peasy, because you never do any rollback, ever. Ever. We are good engineers. We are great engineers. Well, you are. And you don't do any rollback. Because now you need to do rollbacks, and what happens is back to square one. So we need to think about our not compatible schema changes in a succession of one step forward and one step backward compatible changes. So this small change, we need to split it to break it down into compatible changes. I have a simple use case. I created first an application, I designed the database schema badly, and I want to upgrade it now. But now my app is actually used by millions of users. So I cannot just put everything away. I want to be zero downtime. So I have this table, and I want to split it into two different tables with a simple primary key, foreign key relationship. It's a good use case. It happens. So I have this database schema, and as you can see, I didn't go to university. I didn't study database design because actually I put the address and the person into the same table. So I want to do it like that. So the previous version, one table. The second version, two tables. That's a good use case. And this is clearly not a breaking change. How can we split it? Well, the first step is actually to create the new table. And now every time you update or add or whatever data on the first table, on the big table, then you will replicate this change into this new table. That's the first step. If you need to roll back at this point, that's fine because, the first person table still has everything. The second step is to move from the source of truth being the person table to the source of truth being the address table, but still you replicate, but in the other way. So every time you do changes on the address table, you will copy to the person table. If you need to roll back, again, that's fine. We have everything into the person table. And finally, you do some cleanups and remove the constraints and blah, blah, blah. And afterwards, you are all set. Everybody agrees with that? Cool. Now, if you are using Spring Boot, you know that Spring Boot tries to be your friend all the time, tries to do stuff for you all the time. And one of the things it does is if you have entities, GP entities, it will create the schema for you. So when you deploy the new 2.0 application, it will update the schema for you and make it incompatible with version 1. So the first thing to do is to disable this feature. So we want to be in control, but still we need to automate a lot of stuff. And for that, we will need to delegate to a tool. And in the Java ecosystem, there are two tools. There is something called Flyway and something called Liquibase. So I chose Flyway because I knew the guy who was behind it. You can choose Liquibase. I probably assume that in your own technology stack, you have the equivalent. If not, create one. It's really good. And basically, Flyway or Liquibase is just like version control for your database schema. Like, at some point when I was younger, I always thought, but if there is a problem with the schema in production, if with the database, how do we recreate the database? You should store it somewhere. You should be able to recreate your schema with all the changes from somewhere. So you need to add version control for your schema. And again, Flyway or Liquibase is the way. Very, very fast introduction. On Flyway, you have something called migration. Migration is just a SQL script. Just a SQL script. You can put whatever you want in it. It is versioned. In the name of the script, it has a version number. So basically, Flyway is able to say, oh, this is version 1.0. It needs to be executed before version 1.1. And afterwards, it will be version 2.0. Every time it executes a script, it will record it in the database itself. A script that has already been executed won't be executed twice. So even if you have a different application with the same script that gets executed, only the first one will execute the script. The second one will check that it's already done, and it won't redo it. There are a lot of different ways to execute Flyway. You have a command line, you have job, blah, blah, blah. But basically, we will use Spring Boot integration because we are already using Spring Boot. So how do we integrate it? You have a dedicated folder for that, DB integrations, so author, C, main resources, DB migration, sorry. And then you put all your script into it, and it will be executed at startup time by the application. So what I wanted to show you into this talk is actually that zero downtime is possible. It's not possible because Kubernetes. It's possible because you can do it. However, it's far from free. Like if the business comes to you just 1 week before release and, hey, let's do zero downtime, tell them no. Yes, it has benefits, but as always in our industry, it has a lot of costs. In that case, the cost is you must think about it before. You must design your changes so they are compatible. You must break those non-compatible changes so that they are split into compatible changes. It requires technical skills, and it requires a lot of planning. This was for a simple, stupid demo. Now imagine you have a real software, and you have, let's say, 10 feature branches. And among those 10 feature branches, 5 of them have schema breaking changes. So you need, in those 5 feature branches, you need to split them up into different changes. Release is going to be fun. That's not to say that's not possible. That's to say you cannot decide from day 0 to day 1, hey, let's do zero downtime. And everybody should be involved. Like developers should be involved, like database administrators should be involved, project managers should be involved. Everybody should be involved. It's really a team effort. And of course, business. So thanks for your attention. I'm sorry the demo didn't work. You can read my blog. You can follow me on Twitter. And you can get the repository for yourself and check that it really, really works. And yeah, and let me know that it works for you, please, because otherwise I would feel very bad. And perhaps now we have a couple of minutes for questions. Any question? Yes, question. Wait, you will get the mic and it will be recorded.
Well, it's just a simple question. Is this Flyway or Liquibase have any performance issue?
Any performance?
Any performance issue?
Any performance issue? Well, it's software, so as any software, it has bugs for sure. But basically, it's just a script that you run before your application starts or whenever you want. So it should do nothing. The only thing that it does is basically when it creates something, when it changes your schema, it locks everything so that you don't run into concurrency issues. So meanwhile, your other pods, they cannot change the schema themselves, which is fine. Otherwise, everything is fine. But again, there are bugs everywhere in Kubernetes, in my demo, in everywhere. Other questions?
Hello, a nice presentation.
Thanks.
We are actually using Flyway, and I have a couple of questions because, for example, right now, our Flyway is configured to check the database. So if you try to deploy an old version of the application with a new schema in the database, Flyway is giving us an error because it checks the checksum of the scripts in the old version and it doesn't match with the with the database?
Okay, my experience, I don't know about your problem, but I know about the symptom of your problem. Like, hey, you probably changed the checksum. That's not that you deploy a new version. What you did, what I did also, is basically you applied a script, let's say v1.0, and the checksum is recorded in the table. And now what you are doing is you are changing the v.10 script. Like in Git, once you write something, you shouldn't tell it. And what it does, it's the checksum of the new v1.0 is not the same. And it tells you nothing. I will do nothing because you try to cheat me.
Yeah, that's the point.
Yeah, that's the point. So actually what you should do, you should get back to the old v1.0 and create a v1.0.1 that does what you wanted, the gap, and then you can apply it.
Okay, okay.
Don't try to cheat Flyway.
Yeah, good advice. And the other question is, what about a failure in the scripts? How can you deal with those kind?
At this point, it's like everything. You try to automate everything, and then you have failures, and then you need your hands and you need your brain and to understand where, why, what. There is no black and white answer there. I mean, you need to work by yourself. Yeah, and it happens. Yeah. It can happen.
Yeah, we are discussing this matter right now. Some people are in favor of putting undo scripts inside Flyway. I'm not in favor of that choice.
Actually,
I want to know your experience.
Well, I'm a Spring Boot user, and actually there is no integration with undo scripts with Spring Boot. So I never use them. I know they exist. I know they are pretty good. But you must think about, hey, what's the real undo? Like, because Flyway, you can have like scripts, but you also have the way to roll back them. But then you need to write everything by hand because there is no way for Flyway to know the exact opposite action. So you need to write the opposite action by yourself. It's a very good way because, again, you have everything under version control. But the thing is, if you apply an undo, I don't know how does it work with the version history in the database because I never use them. What I assume is it will either write a new line saying, hey, I've undone it, and then the next time you can start from the old new version, or it removes the line entirely, which wouldn't be super good, but I've never used them.
Okay, thank you.
Thanks. Other questions? You had a question before.
Yeah, well, I've been creating during this time, and I think that that's the key. So, as I have seen, when you change version on a not exactly compatible way, you need to do 3 steps on your code. Like, okay, now we have the address table, so we need to replicate in code, and then after some time, we have to cut that code because we don't need to replicate anymore, and then forget about to put the address on the person table and just keep on the address. So if we are going to do just one change on the database, we will need 3 changes in code.
And what you don't mention that is very important, you can only get back one step. You can only get back one step.
Thanks.
Yeah, you cannot go back 2 steps because your changes, they are compatible side by side, but not 2 sides by 2. So that means that every time you have such a database schema breaking change, you need, depending on what you're actually doing, in my example, there were 3 steps. You can have less, you can have more, I don't know, but in this case, there were 3. You need to apply them, check that everything works. So tests in production, wait until everything is stable, you are sure that it's fine, and proceed further. Because once you proceed, you can only roll back by 1 step, not by more. So in my example, I had a 1.0, 2.1, 2.2, 2.3. You can roll back from 2.2 to 2.1, but that's all. You can not roll back further.
Yeah, okay, so basically the moral of this is that if you have a breaking change in the database, you can do it. It will cost, so think before.
Yeah, exactly. Like, that's my takeaway. It's possible. So if you have real business reason to do it, but don't do it because it looks nice on your resume. Don't do it because your grandmother expects it. Do it because it's really an advantage, a competitive advantage in your business. Because the costs are not trivial. Other questions? I think it's time anyway. So thank you a lot. Unfortunately, I need to go now, but you can ping me on Twitter. And yeah, if you still have questions, I will be happy to answer them. Thanks. Have a good day.